After performing two successful moon landings, NASA had solidified its position as the forerunner in the space race, outshining the Soviet Union. And now, they were ready to do their third exploration around the moon. Apollo 13 was launched from Cape Kennedy, Florida, by a giant Saturn V launch vehicle and only minutes later was inserted into orbit around Earth. The crew included Commander Jim Lovell and lunar module pilot Fred Hayes, who were scheduled to land in the lunar module Aquarius and explore the Fra Mauro region of the moon. But this was not going to happen. Welcome to Lucky Life. Today we are talking about April 11, 1970, where a Saturn V rocket pierces the sky, carrying Apollo 13 and its crew on what was meant to be NASA's third lunar exploration. But just hours into their journey, a routine check triggers a series of catastrophic events, leaving the astronauts stranded in space. From near-fatal setbacks to ingenious solutions, witness the resilience of the human spirit amidst the vastness of space. How did they defy the odds and make it back home? Well, let's get started. As the countdown clock hit zero, the crew, led by seasoned NASA astronaut Jim Lovell, prepared for liftoff. Joining Lovell were John Jack Swigert, tasked with piloting the command module, and Fred Hayes, set to pilot the lunar module, both embarking on their maiden space voyage. On April 11, 1970, the trio boarded the command module, affectionately dubbed Odyssey, perched atop a towering Saturn V rocket at Florida's Kennedy Space Center. The launch drew a modest crowd of about 200,000 spectators, highlighting a declining public interest in space exploration compared to the enthusiasm witnessed during the Apollo 11 liftoff a year prior, which drew 7 million spectators. Approximately 56 hours into the mission and over 205,000 miles from Earth, the crew concluded a live TV broadcast, be it with limited interest from television networks. Houston flight controllers, noting a slight dip in pressure, instructed Swigert to conduct a routine check on the oxygen levels in the service module, SM, by initiating a cryostir on the tanks. This is where things went horribly wrong. The crew heard a loud bang from outside and called down to Houston to report, with Swigert famously saying, "Okay, Houston, we've had a problem here." Both the astronauts and the ground team at Mission Control observed alarming readings indicating trouble with the oxygen tanks and fuel cells. Oxygen tank 2 had been completely drained, while tank 1 was steadily depleting. Initially, some at Mission Control suspected instrument malfunctions, but Lovell's observation of gas visibly leaking from the service module confirmed the unsettling accuracy of their data. Subsequent investigation revealed a harrowing sequence of events. An electrical surge during routine testing had triggered a catastrophic failure in one of the oxygen tanks, essentially turning it into a ticking time bomb. When Swigert initiated the stir, it unknowingly triggered the explosion, blowing a sizable panel off the service module. With power and oxygen reserves reducing rapidly, the mission's objective shifted abruptly from lunar landing to ensuring the crew's safe return to Earth. A critical decision was made to conserve the remaining fuel cell in the command module for re-entry, an impossibility in the lunar module known as Aquarius. The crew, facing cramped conditions and limited resources, would evacuate to the lunar module, repurposed as a makeshift lifeboat due to its independent life support system. However, this posed a significant challenge. The LM was only designed to support 2 astronauts for a brief lunar excursion, not sustain all 3 men for the extended journey home, which would span 4 or 5 days cramped inside the capsule. As the spacecraft drifted a staggering 157 miles beyond the moon's far side, another critical maneuver was plotted to speed up the journey just 2 hours past Pericynthion, the moon's closest point. There was deliberation over whether to ditch the service module to accelerate further. Still, concerns arose regarding the command module's heat shield being exposed to prolonged freezing temperatures in space, risking its integrity upon re-entry. Moreover, opting for this would deplete all remaining fuel, leaving no room for future course corrections. NASA opted for a safer 4-minute burn, trimming 12 hours off the flight path and aligning the craft for a Pacific Ocean splashdown. Almost a day post-explosion, the crew executed another successful burn. As the spacecraft drifted a staggering 157 miles beyond the moon's far side, another critical maneuver was plotted to speed up the journey just 2 hours past Pericynthion, the moon's closest point. There was deliberation over whether to ditch the service module to accelerate further. Still, concerns arose regarding the command module's heat shield being exposed to prolonged freezing temperatures in space, risking its integrity upon re-entry. Moreover, opting for this would deplete all remaining fuel, leaving no room for future course corrections. NASA opted for a safer 4-minute burn, trimming 12 hours off the flight path and aligning the craft for a Pacific Ocean splashdown. Almost a day post-explosion, the crew executed another successful burn. However, a new issue surfaced: rising carbon dioxide levels. The lunar module's air scrubbing system wasn't designed to handle 3 occupants, and projections indicated that the lithium hydroxide canisters, which absorbed carbon dioxide, would only last on return. The command module had its canisters but needed to be compatible due to design differences. Houston brainstormed a solution using only materials aboard Apollo 13. After 35 hours of experimentation, they devised a fix involving spacesuit hoses, plastic bags, and duct tape. The next step was to scrap the damaged service module while using the lunar module's thrusters to create distance. This provided the crew their first glimpse of the explosion's aftermath, which they relayed to mission control. Subsequently, the lunar module was detached, employing a last-minute procedure to pressurize the connecting tunnel before release. The calculations proved successful, and the crew bid farewell to Aquarius, the resilient module that had carried them this far. On the morning of April 15th, Apollo 13 finally came back under the gravitational pull of Earth, still quite a distance away at about 216,277 miles. It was determined that a minor adjustment was needed for the accelerated trajectory, so the lunar module's descent propulsion system was fired up once more. Thankfully, the correction went smoothly, and the journey continued. Inside the lunar module, the temperature had plummeted to a chilly 38 Fahrenheit, 3 degrees Celsius, causing condensation to form on the walls. Despite the discomfort, the exhausted astronauts managed to catch some restless sleep between receiving instructions for the upcoming spacecraft separation and re-entry maneuvers as they neared Earth. The first step in the re-entry process was to detach the service module, leaving the command and lunar modules linked together in a configuration never before attempted. The astronauts seized the opportunity to snap valuable photos of the damaged service module, revealing the extent of the explosion. Lovell remarked on the gaping hole in the spacecraft, noting debris hanging out near the antennas. After transferring back to the command module, Odyssey, the crew powered up the life support systems, which had been shut down to conserve resources. The 2 modules were then separated, allowing the pressure in the connecting tunnel to push them apart. And then, with the astronauts safely inside, the command module entered Earth's atmosphere and made a precise splashdown at the designated target time of 1:07 p.m. Eastern Standard Time on April 17th. This marked the end of their tumultuous journey, lasting 142 hours, 54 minutes, and 41 seconds from the thunderous liftoff of the mighty Saturn V rocket. Miraculously, the astronauts emerged from their ordeal without any lasting health effects. Despite the ordeal, NASA deemed the mission a successful failure due to the invaluable lessons learned. Enhancements were swiftly implemented, including additional batteries and a separate reserve oxygen tank for future spacecraft. Such crises were averted across 8 subsequent Apollo missions, marking a testament to NASA's resilience and adaptability. So, what lessons can we learn from this successful failure that still resonates in our quest to explore the universe?